Hello students, welcome to the next chapter of class 11, that is Permutations and Combinations. The name of chapter and the concept is altogether a different approach, permutations and combinations. This is something that you haven't learned yet in junior classes. Before going to these major terms, permutations and combinations, we have to deal with a unique way of thinking in performing a particular task in different ways. Now you have to develop your mindset in a way that to start thinking like how can these things be done in the basic manner without using any formula. So when we talk about these two things, permutations actually means arrangements. In practical life, these two things are very important. When we have to arrange few things in a particular order, provided there are some restrictions and some conditions. So those arrangements of people or things or objects can be done. That permutations is arrangements. When it comes to combinations, it is layman language, we call it selection. If we have to select few objects or few persons from a group of people, then in how many ways we can perform that selection, provided we have some restrictions or some conditions applied on that. So basically what it is, permutations are arrangements of objects. Combinations is selection of objects or people, right? So we will deal with these two different phenomena in detail in the second video. Right now, I would just explain you how to think of these in practical manner when you have to deal with day-to-day life problems. So first you have to build a thought process. You have to start thinking like that. If you can perform a particular thing in so many different ways, what are the total number ways, right? So before that, we have a theorem which is called fundamental principle of counting. Fundamental principle of counting, right? See, the theorem says if there are two jobs such that one of them can be completed in m ways, first job can be completed in m ways. And when it has been completed in any one of these m ways, second job can be completed in n ways. See, we have two basic theorems. Fundamental principle of counting. The first one is multiplication and the other one is addition. Now, you have learned these basic principles in sets. In sets, you have learned that when we have to perform two functions or both the functions, then the multiplication thing comes into the scene, right? Like if we have something in A and B, that is A intersection B, or we can call A into B. Similarly, now start thinking this way. Like first job can be done in m ways. That has to be followed by another job which can be performed in n ways, right? Now, in how many ways we can perform both the jobs? Where first job has to be done followed by the second job, right? That is m into n ways. This is basically the fundamental principle of counting in which we have to use multiplication, right? So the other one is, let's say, the first job can be performed in m ways. First and second. Here both have to be performed. So I write first and second. Now the first job can be performed in M ways. The second job can be performed in N ways. Now what happens if a person has to do either of the two jobs, first or second? So he can either do the first job, which can be done in M ways, or in sets, if you remember, A or B is A plus B. So if he chooses to do first job, he can do it in M ways, or he can opt to do the second job, which can be done in N ways. So in all, either of the two jobs can be done in M plus N ways. Right? This is the principle of addition, in which we have to perform both the jobs. It is multiplication. So always remember, when we have to perform more than one, then those come into multiplication. And when we have to perform either of 1, 2, or 3, then we take them in sum, either this or this, right? Like, let me give you few examples here. Given 4 flags of different colors, right? We have different colors. 4 flags of different colors. The question says, how many different signals can be generated if a signal requires the use of 2 flags, one below the other? Now, these are 4 different flags. We have to generate a signal, right, which requires use of exactly 2 colors, right? How many different signals can be generated if a signal requires the use of 2 flags, one below the other, right? Now, this signal has to be generated. This is the first color. So, the different colors have to be used. How many options do we have for this color? We have 4 different options. So, we can select the color for the first flag out of these 4 different colors, right? Let's say this has been used. So now remove this from the choice. For the second color, we are left with these 3 different options. So now how many choices are there? We have 3 different colors from which we can choose the second flag, right? Now, if we have to create this signal, that means now apply which principle is to be used, multiplication or addition. We have to choose this color as well as we have to choose this color, because the signal will be, see, question will never tell you what principle you have to use. They will not even ask you and or every time. You have to see how this whole thing can be done by taking both or by choosing one, right? Here we have to take both. Why? Because if you have to create the signal, that doesn't mean that you can only choose one first color and do not go for the selection of the second one. That means you have to perform the choice for this one as well as this one. So both the jobs have been done. The first one can be done in 4 different ways. The second one can be done in 3 different ways. So in all, you can make 12 different flags in which you can select 2 different colors, right? So the number of different signals which can be generated is 12, right? So the question will not clearly say you have to use multiplication theorem or addition theorem. You have to use your mind to see how is the question have to be dealt, right? Now the next is, a room has 6 doors. A room has 6 doors. Let me represent it pictorially so it becomes easier. So when you try thinking this way, this is a new thing that you are learning in this class, but it is interesting. So once you are thorough with understanding this basic counting principle of multiplication and addition, then you can easily grasp the formula for permutations and combinations, right? A room has 6 doors. In how many ways can a man enter the room through one door? See, there are 6 doors, but he has to choose only one to enter into the room and come out through a different door, right? Now, when it comes to entering the room, he has got 6 different options. 1, 2, 3, 4, 5, 6, right? He has got 6 different options. Let's say he can, how many total choices are there? For entering, he has got 6 choices. Let's say he chooses this one, right? Now, he has to leave the room through some other door. That means if he has entered through door number 5, leave out for this door for the selection into the second category. This has been used. Now he has to select one more door to exit the room. For exit, he has got 1, 2, 3, 4, 5 options. That means he has to choose one door to enter the room. The other one has to be selected to leave the room. So in how many ways he can perform both? Because he has to enter. Now the question is not telling you that you have to do multiplication or addition. He has to enter through one door and he has to leave. That means and is he has to perform both the functions, right? In how many ways he can do this? He can have 6 choices to enter and 5 choices to leave. So the whole operation, both the jobs can be done in 30 different combinations or 30 different ways, right? So these both were the examples of multiplication, right? Now, let us say a question is there. Find the number of different signals that can be generated by arranging at least 2 flags. At least 2 flags in order, one below the other, on a vertical flag staff. Like you have a flag staff like this. If 5 different flags are available, now you have 5 different options for colors, right? Different flags are there. But now there's a difference in the question difference. At least 2 flags. I'm reading the question again. Find the number of different signals that can be generated by arranging at least 2 flags. Right? You have to create a flag in which minimum number of colors is 2. But see, how many options are there? When you have 5 different flags available, at least when you deal with at least type of things, minimum number is 2. And what is the maximum possible number? It is 5 because you have got 5 options. So at least 2 flags. If we create a flag like this, we have only 2 colors. This is minimum number. Next possible number can be 3. 1, 2, 3. Next possible number can be 4. 1, 2, and the last can be 1, 2, 3. What is the value of at least? At least 2 flags means you have to generate signals in which minimum 2 numbers should be there. 2 different colors should be there. So now we have 5 options for this color. We have 5 different flags. So we can have 5 options for this color. And since we have to use different colors for flags, the second option is for 4 colors. The second flag can be chosen from 4. If we have used this one, you can have rest of the 4 for the option of second flag. So now we have to use minimum of 2 flags. So 2 flags, if we use exactly 2 flags, how many signals can be generated? 20, right? Now, if we have a choice, we have to use minimum of 2, but maximum goes up to 5. They will not restrict us. We have to see our availabilities. Now, the second type of flags is we use 5 colors for the first position. We have 4 options for the second position. And then we are left with 3 options for the third position. So 5 times 4 times 3. We can create 60 different signals which use 3 different colors, right? Same is the case of 5, 4, 3, 2. So when you multiply them, this is 5, 4, 3, 2. 62 is a 120. And this remains the same because the fifth one is automatically the last one which is left. So again, we have 5 times 4 times 3 times 2 times 1. This is 120. Now see, the question says you have to use at least 2 flags. It's not exact 2, right? We had done the first question in which we had to use exact 2 colors. So at least 2 flags, it is 20. Then if we go on higher end, we can use 3 colors also. That is 60. Then if we use 4 colors, this is 120. If we create a signal with 5 different colors, it is all 120. So now when we have at least 2 flags, so that means here the principle of addition comes into this. When we talk about selecting colors for one flag, we have to use our choices. So this and this. So we multiply. So principle of multiplication comes into the scene. Here also principle of selecting 3 different colors comes into the scene. So we have already used the principle of multiplication. But the signal can be created this way by using 2 colors, or it can be created with 3 different colors, or it can be created with 4 different colors, and finally it can be created with all the 5 colors. So these are the different ways in which the signal can be generated. So these are the different ways. Now we can perform this function in any of these ways, any of these. Then principle of addition, right? This or this or this or this. So all these different ways can be added. 240 and 6, 300. So 320 ways are there in which we can create signals in which minimum of 2 colors are required and maximum of 5. So I have added these values, not multiplied, because here we have a choice. So when we have a choice, we can perform this way, that way, or in multiple 3 or 4 ways. All the ways have to be added, right? So this was very basic and conceptual things. Since you had not learned these things in junior classes, you have to develop your mindset and thought process so that you can look for all such options and then see how these things can be performed. I hope that whatever I have told you right now, that is clear to you. Still, if you have any doubt, you can ask me, you can contact me, or if you want to plan classes with me, do contact me through Apple. Thank you.